Hey, this is today's lesson. Uh, Oopsie, I froze a little bit here. Okay, here's today's lesson. What we have here is a series of double replacement reactions, and I know you know what a double replacement reaction is right now, so that's good. And these double replacement reactions, what's going to happen is we have solutions. And so, for instance, this is potassium iodide. Right here, I'm looking right here on my table. Let me highlight this one. So this is where I'm at. So I have potassium iodide. My thing keeps freezing here, so let's just see what happens. I have potassium iodide, and I have, it's backwards, but lead 2 nitrate. Okay, and I have the things that we have listed here. And what I'm going to do is I'm going to mix them together in a test tube. And let's go big screen here so you can see a little bit better. Hey, look at that. Okay, so test tube, pretty clear. I'm starting off, this is the lead nitrate. And I'm going to pour a little bit in this test tube. And lead nitrate is dissolved in a solution, right? It's in water, and all of our ionic compounds are dissolved in water. So lead nitrate is no exception to that. And remember, when things dissolve in water, they dissociate, which means the little particles separate apart. It's PbNO3, 2. So there's 1 Pb, 2 nitrates, and they're all separated, and they're floating around in this solution. They're dissolved. They're dissociated. They're split up. They're moving all over the place. Now, before an ionic compound can really react, it has to be dissolved in water because it has to be mobile. If it's frozen, I say frozen, but if it's in a crystal state, it's not going to react because it has no way for the particles to move and touch. So we're going to add, I guess that was my potassium iodide I think first. So now we're the slight yellow tinge to it. Then we're going to add our lead nitrate. And the lead nitrate is also dissolved in water. And I'm going to add these two together. And they're going to form a product. It'll look good against this black sweatshirt probably. And we're going to form a product that doesn't dissolve in water. And you can see that. Ooh, it looks really good. And now that solid, that form there, because it doesn't dissolve in water, it's a solid, right? That solid that forms there is called the precipitate. The precipitate. And it precipitated because it no longer, or it doesn't dissolve in water. So it's made of little pieces, parts, and a little bit that will settle out. I have another example back here. Right? It'll settle to the bottom. And as you can see, it is definitely a solid sitting in the bottom of this tube. Right? So what we're going to do today, doesn't fit. Okay, so what we're going to do today is we're going to figure out what chemical, what is that precipitate? What thing is not dissolving? All right, so let's go back and we're going to look first at, ooh, looks like I'm peeking around the corner. Ooh, who's that guy? All right, so we're going to look first at this compound that we just did, the exact problem we just did. All right, and let me make this a little larger so we can see it. All right, so what we have is lead nitrate and potassium iodide, like we said before. So we write down Pb. Now, it doesn't matter what you lead with. You can do the K first or the Pb. Whatever cation you want to start with, that's fine. So Pb, and they're going to switch partners because this, remember, this is a double replacement reaction. So they're going to switch partners, and the Pb is going to be grouped up. I just wrote the same thing it's with already. It's going to be grouped up with the opposite ion, the other partner, which is I. So Pb plus 2, I is minus 1. Remember what we do? We crisscross those charges. So nobody's going to put a 1 there, but we could put a 1 there and a 2 there. Right? So that's lead iodide, lead 2 iodide. Plus K. Now K is going to go with the other ion, which is NO3. Right? And that's our double replacement reaction. Now, this is just showing the reactions. There's something that's called an ionic equation that will make this look a little bit different than this, but we're not to that stage yet. So if you're not in my class and you're watching this and you're going to say, no, 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 that's not right. Well, I know it's not correct yet, but we will get there eventually. All right, so before we go on, let's balance this equation. We have two NO3s on that side. Now we have 2 on both sides. We have 2 Ks on the right. Now we have 2 Ks on the left. We have 2 I's on the left, and we already have 2. Oops, I didn't write. I've got a little lag going on here, everybody. Oops, we crashed. Hey, I'm back, but I have crashed. Let's see what's going on there. And action. Okay, I'm back. I'm not lagging anymore. My screen's back. I guess I'm still lagging. I don't know what's going on here, but so we have our equation balanced now. Now, what we're going to do next is we're going to determine which of these things is the precipitate and which is not. And to do this, you need the solubility chart. And the solubility chart is in Schoology. It's called solubility chart, and it looks like this. Now, I've made a few little marks on here. Why is that doing that today? I have the iPad pressed up against the camera button. That's the problem. Okay, so we have this ion chart here. And so we look at the first line here. It says all. All are soluble. And what this is talking about is the alkali ions. So on the first column of your periodic table are the alkali ions, right under hydrogen. Lithium, sodium, potassium, rubidium, cesium, and francium. Those are the alkalis, and they dissolve no matter what compound they are attached to. I'm not sure what's going on with this thing, but it's driving me nuts. It never does this normally. Let's turn this off. Okay, so it dissolves no matter what. All right, and so it's soluble. Soluble means it dissolves. And then also in that same line, hydrogen ions. Hydrogen always dissolves. Okay, so hydrogen is soluble no matter what compound. And that's the cation hydrogen. And then our favorite polyatomic ion, cation, ammonium, also dissolves. So those first 3 things always dissolve no matter what, and they're the positives. And then they also throw nitrate on here. Nitrate is a negative ion, anion, and it is also soluble with everything so far, okay? So those 4 are like the set things that we can look at, the shortcuts. Now, we go further down the chart. All right, from here on down, it's talking about the anions, and you're going to match up the anions with what, with their cation, and you see if they dissolve or not. Now, it says low solubility. The reason they're writing low solubility instead of precipitate or doesn't dissolve is because small or trace amounts of everything, almost everything dissolve at some point, just not very much, right? So low solubility is a safe bet, a safe way to say that it's not going to dissolve very much, which means it's going to be the precipitate. Okay. That's not what we want to do. All right. So let's see what we go here. Let's change this so it's just presentation mode. There we go. And so our compounds that we looked at before were we're only looking at the products, right? They were lead iodide, PbI2, and then potassium nitrate. So if I'm going to do the short one, I'm going to do the easy one first. Looky here. K, right? That's an alkali. All the alkalis dissolve. All the alkalis dissolve, right? So that KNO3 definitely doesn't dissolve because I see that K there. So that's a shortcut. You find that alkali, you know it's not going to dissolve. Also, look at here, nitrate. Nitrate always dissolves. So this is like a double whammy here. This definitely is not our precipitate in that reaction. So it's going to be the lead iodide, okay? So we're going to look at PbI2. And let's go back to the other chart so you can see it. I should have done split screen here for you. If I knew how to do that, I would do it. And here's what we have. So we're going to go down and we're going to find out which anions with. So we go down the list here. And of course you saw me pass it already because I'm showing you the whole list. But what do we have? All these anions on the side. But right up here, right there, iodide, right? And so what's it say? All others soluble. Well, that doesn't mean much to us. So let's look below the dotted line. Ag, Pb2, lead 2, and copper 1 have low solubility. So lead 2 iodide is our precipitate. Now what we're going to do is we're going to circle it. And you know what I'm going to do? I'm going to do better. I'm going to highlight it in lead, iodide, yellow. Ooh, look at that. And we know that's our precipitate. Okay, so let's go back through this again. What do? We're going to balance the equation. KCl plus minus 1. No subscripts needed. Mg is plus 2. PO4 is minus 3. Crisscross, 3, 2, right? Okay, balance the equation next. We have 3 mg's on the right, 3 mg's on the left. 6 CLs, 6 CLs, 6 Ks, 2 times 3, 6 Ks, 2 PO4s, it's all balanced, okay? That's done, easy peasy. Now we're gonna try to find that precipitate. Look, right there. Look at your table, first column under H, K's in that column, alkali metal. This definitely is not your precipitate. All right, so we don't really have to check it because we did a quick check. We looked and saw if there's an alkali. Now we have to check this one because some of these do not have precipitates. So you have to check both of them. And we'll go back and let me show you the first one. Look right there. If it has a K, oops, I just scribbled it out. If it has a K, it is not the precipitate. Okay. Now the other thing that we were looking at was phosphate. And oh, the very bottom, looky there, phosphate, right down here. And so phosphate is soluble with all the alkalis, of course, because everything is. With H+, of course, because everything is. With ammonium, of course, because everything is, right? That wasn't telling us much. We knew that already. But it is insoluble or low solubility with everything else. So the phosphate compound is, the magnesium phosphate compound is our precipitate. Now it's not going to precipitate out yellow, but I have that color highlighter on. All right, so doing this equation should be pretty easy, especially doing the double replacement reactions. You should have no problem. I have the charges on there. Just follow the same rules we've been doing. And then use your solubility chart to figure out which is the precipitate and which is not. There are 2 that have no precipitates. So just warning you. Okay, I hope that helps. I have to edit this down now because my computer went wacko for a little bit, but hopefully it's under 10 minutes. Have a great day.